G'day guys. I hope this is the last video I make for today. Oh God, been out running around in the bush, doing stuff here, everywhere. But we don't know what's going to happen tomorrow with these crazy fires. There is now something like 400 um, fire guys or fire people. I think women are in it as well now. Yeah, setting up at Victoria Park as base camp for a massive firefight tomorrow. We're going to have horrible weather. We have fires basically northeast of Ballarat, and I just found out they're burning on a 200-kilometre front. How do you put that out? 200 kilometres in the bush. Okay, and this, I'm going to get this in while I can. Think about all the work the greenies have done blocking off access to our parks and national parks, whatever. You know, anything they deem as, oh, that area is protected. Well, guess what? You've cut off all the access. You can't get in there and put the fires out, and the whole lot is going to burn to the frickin' ground, right? Remember they tried to kick prospectors out of areas. Oh, you're going to get a huge fine if you walk off the marked path and all this. Well, isn't it petty? It's so petty considering that these big fires are coming through, and some of the areas they have big metal and big pine vertical bollards smacked into the tracks. You can't get access. It really is freaking dumb. It is so dumb. So when something starts up, there may be a little spotting. A fire jumps ahead, embers carried in the wind, set something off further, along where the wind's blowing. It catches on fire. It's really small. Well, the fire trucks can't get in there to put it out, and it turns into a massive blaze. I've always thought that, how dare you be so stupid, right? Stupid. And these stupid bloody things they've got. You're not allowed to go into certain areas and pick sticks fallen on the ground for your wood fire at home if you've got one. You can't do that. No, leave it all there so it burns the forest down, gives massive fuel load to these fires and really gets them going at ground level. It is just pathetic. Anyway, I've had my beef about that, but tell me I'm not freaking right. Tell me I'm not 100% right. Unbelievable. Save the koalas. Yeah, right. It's what we're going to have, barbecued koalas tomorrow. Well, probably we got hundreds and thousands of them anyway. But this is what I'm getting at. They're protectionist, knee-jerk responses. Keep people out of the bush. Well, guess what? You should have put a sign up: no fire allowed. Oh, Jesus, devil's not allowed. Whatever. Now it's all screwed. It's all screwed now. It's going to be black and charcoal for years and years. Fantastic. And they'll probably still try and protect the charcoal. They'll come up with some bloody excuse. I'm pissed off about it. I really am. So anyway, yeah, I am, because I can see what's happening. The amount of smoke billowing up into the sky at the moment is absolutely horrendous. They're going to be pushed hard tomorrow trying to stop this thing coming through Ballarat and burning the place to the ground. It's right on the, the warning areas are right to the edge of the town. I don't think if the winds pick up and there are a northwesterly wind, we are going to get a bloody firestorm. Okay, it'll be like Dresden. If it gets out of hand, it'll go through. And go look up Dresden, have a look at that. So, not trying to scare anybody, locals, but the sheer stupidity, you know, of green, oh, save the bush policy. It doesn't save the bush. It causes a bloody disaster you can't deal with. You can't access. You can't get in there at all. Fancy a fire truck going down into the bush to put a fire out, and then there's these big metal poles jammed into the ground on the track in front of them. I mean, what do you think they just go, oh my God, here we go. We got stupidity at work again. And that's exactly what's happened. So it's all through Creswick as well. Watch and see what happens if Creswick, the big plantation forest there, ever go up. And the fire brigade go in there and there's these bloody bollards on the tracks. Ah, just absolute, what a shocker. I'm trying to choose my words carefully because there's going to be some clangers come out. You know, I just can't, get over it. It's like a lot of people would probably look and go, oh, that's a bit silly. It's more than silly. It's criminal. It's lack of forethought and criminal. That is my opinion. Anyway, on to the detectors before I rant too much about that. But yeah, we'll see if we're still here tomorrow. Might have to evacuate and run away, but we'll see how it goes. Now, guys, on these GPXs, the metal box ones, actually this is for all the detectors. I'm going to tell you a little secret. It's not really a secret. Well, it's just an observation. When I have done some upgrades on detectors, and I keep getting people who just really want to push the gain, and I say, you don't really want to push the gain. They go, no, I need it to go deep. And anyway, story is that they want it to go deep and they want to use big coils and they want to crank it up. And sometimes that's counterproductive doing that, but we keep the noise low, give it a bit of oomph. Yeah, it does help. Of course it helps. You get more gold, and it's a proven fact. But these metal boxes, sometimes when you're pushing the gain very high and you've done everything you can to make the detector very stable, very, very stable indeed, and it's in on the bench, like not like that, but hooked up to the battery, to a coil, rate and cancel mode, tested on targets, make sure she's got full ground balance, make sure you're not saturating the whole front end of it, make sure you got enough dynamic range. You just check everything and just make sure it's going to work and perform. This is what I've noticed. It works a particular way on the bench. And you go, fantastic. Then you put it back in the box. And you'll notice that some parameters change. And it's very perplexing because you take it back out and it works fine. You put it back in the box and you may have an issue that, say, in double D, using a double D coil, at near maximum gain, you'll get desensing, where the actual detector starts acting like it's got way too much gain and it's all banged up and it starts getting into itself and you get a reduction of gain. So you're losing signal from targets. You're better off cranking it back a bit and those signals then are detectable. But if you want maximum depth, you don't want that to happen. Now, I was having a bit of a think about this, today, and I said, well, maybe we should actually do a test. And I've done a couple of tests, but I think I better let the cat out of the bag now because a lot of you guys can do this yourselves. Okay, so it's not that difficult if you're a little bit tech savvy or you have a friend who's tech savvy, and it does involve pulling your detector apart and popping out those mylar strips that go into their connectors, black connectors there and there. These were glued in. The glue doesn't hold, by the way, it just pops straight off. Uh, sorry about that, but it's true. So yeah, you just pull the mylars, pop them off. In my other videos, I've shown how to do that very carefully. Stick your finger in there and just lever it upwards. Do not put a sharp bend in it. You'll break the copper tracks. Got to be careful when you do that. So how do we keep the detector from going a bit strange when we put the box? We'll put the detector back into the box, we should say. How do we fix that issue? Well, it may sound strange, but it may come into play with what we were saying with the thickness of the wires on coils, with the residual energy whizzing around the circumference of the individual strands and decaying away too slow. Now, you think about it, you've got a big pulse transmitter receiver on the boards, and it's all sitting in a alloy metal box. Now, it is alloy. You'd expect that any currents would die off very quickly. I'll tell you they don't. And there's a way to get rid of it. Okay. Now, you can't go and do what I've done just any old how with any old method. Have a look inside this. I don't know if you can actually see, but I've painted it all black. And what I've done, I've painted it with a graphite conductive paint. Make sure you do not use nickel paint. Nickel is ferrous. Do not use nickel paint for anything on a metal detector. They sell nickel spray cans and stuff. You know, it's nickel based paint. Don't use it. It has to be a water based graphite carbon, basically candle soot, believe it or not, or very, very fine carbon and a conductive binder type of paint. So what I've done, I haven't used the really low ohmage paint because that is too conductive to a degree, and I haven't scraped back the alloy or anything. I've just painted it on, and I've mixed two of my paints together to get roughly somewhere between 100 to 200 ohms per inch, or 25 millimeters, 2.5 centimeters, all the same. So about an inch apart, you get some measurement, 100 ohms plus. It can be lower. You just don't want 1 or 2 ohms. You want something very, very, well, you want it as resistive but still conductive, but in that area of being able to burn up any surface currents very quickly. So the only thing I can think of is either a proximity problem where the case is causing capacitance to the board or to the wires from the coil. I've done experiments here because I've chopped them off and I've got rid of things, and I've done this and I've done that. I don't want to go into all that business because it's tedious. And the way I actually got rid of most of it happening, just paint it black on the inside. So when it's together, you wouldn't even know, would you? The only thing I will say is where the boards go into the alloy channels where they push through, which is this one here, this one here, and this one here, and that one there. So the boards go in like, well, you know how the boards go. I'm talking about GPs. You got on a GP, you got two boards. So GPXs, you have one board, or the older detectors anyway. And don't paint inside the guide channels for the circuit boards because you won't be able to push the boards in. They're tight enough as they are. So just leave those open. It's not enough there to worry about. It's basically just about every flat surface in this has been painted with a conductive graphite carbon based paint. So that takes care of some of that issue. Now, I pull a lot of this stuff from, my past lives, doing different, having different jobs and, different fields, where actually this is completely the opposite. I used to make microwave amplifier and receiver cavities, and these are tuned brass boxes, very, very well made, making them out of 10 mil brass or even Invar in some cases, which is a temperature stabilized brass, copper, something else in it mix. It doesn't move with temperature. They use it in waveguides for radars anyway, but I'm not going to go into that. But we used to polish the inside of these cavities where everything had to be, it was like a tuned circuit and a resonator. And we used to also put resonators in them and little, I'm not going to go into that, it's too complex. But we used to make these things, and we used to make them very, very efficient and without losses. What we used to do is we would polish the inside, and we would polish it down to a mirror finish on this brass or Invar, whatever we were using. And what we would do then is we would get it silver plated. Silver is extremely conductive, as you probably all know. And I think silver's the most conductive metal there is, unless there's some exotics that are more conductive. But we used to get them plated with silver. I used to actually plate them myself with silver nitrate or nitrite. Can't remember, nitrate or nitrite. But I used to plate my own sometimes. And so if we do it in a batch, we get it done commercially. But it was easy enough to do. It was not hard. You do it with about 3 volts and dip it in. And yeah, anyway, we get these things silver plated, and then we would buff the silver and make it very, very smooth, get rid of all the surface imperfections, because at very, very high frequencies, all the little ups and down little bumps, even at molecular level, burn up the RF energy because it's very, very high frequency. So there's a lot of transitions happening per second, and it would have an impact. So, if we didn't do all this, we'd probably get somewhere around 80% efficiency, and then we polish it all and all put it together nicely, and we would be up at 97% efficiency. And when we were doing receivers for radio telescopes, that was very, very important to get those efficiencies. And then you freeze the whole thing in liquid nitrogen to get the temperature coefficient down the whole thing, and make it all a lot more quiet. So the things we used to do, quite amazing. But now it's all probably mass produced in China. This is the days before the internet, basically. And a lot of our experiments was done around 2.5 gigahertz and 5 gigahertz, 10 gigahertz, 24 gigahertz, and 34, I think, where the police speed cameras operate. Oops, shouldn't have said that. But where all this stuff was happening, it's very, very critical to have it all polished to get the maximum efficiencies, to get rid of the losses. But with this stuff, we want the losses. We're trying to make the losses. And the best way to make losses is with this semi sort of resistive, conductive carbon paint. You could probably layer it up and layer it again and layer it again, and it would get rid of any, like say you had some sort of coupling from the transmitter, and for some reason it was getting into a multiplex, and the componentry here was is enough metal and everything else that it was getting affected by the energy, and the eddy currents were still dying away on this part of the board, and it would make the receiver noisy. Well, basically, you're looking at the same sort of effect with this. This can do the same. And even saying that, I'm toying in my head right now, what if I did the same thing over the top of the white paint on the board, right? I mean, you've got to use a very resistive mix. You cannot use a conductive mix because it would add a capacitance effect. We got that out. I see another long day and very little sleep. I probably got 4 hours sleep last night and I'm feeling it. But on we go. So you could actually do that on a board. I don't want to do it. It may have detrimental effects. It may not. Maybe you do a section and try it and just ground it out to this central ground point. You also want to make sure that everything is painted over so there's no conductivity from the paint to the board if you wanted to paint the board. Now, saying that, what detector did we see? I'm trying to remember this. There was a batch. This is interesting because it was a batch of 2100s in the early days that came out, and they had black paint all over the boards. I never tested it to see if it was resistive or if it was just black paint. How's that? I never thought about it. I just said, well, they're trying to disguise the electronics more so than what the white paint does, or so they're putting a black paint on it. Maybe that makes it harder for anyone to, have a look-see. See, that you look at that and you can sort of see what's what there within reason. But if you do it in black paint, it makes it a lot harder. So that's what I was thinking at the time, many years ago when we were playing around with 2100s. I never ever stuck the multimeter into the paint to measure the resistance. I don't know if it was an insulator or partial conductor. I don't know. Well, isn't hindsight amazing when you think about that now? That is interesting. Anyway, there are parts of this that you could get away with painting it over with some black paint. I would probably raise the resistance of the paint when it dries to maybe probably over 250 ohms, just in case. But the other thing too, I've just noticed too, parts of this, obviously, where they put these connectors in, that's not painted. Hang on a sec. This thing's saying something to me. Low battery. Oh, whatever. I'll turn that off. If it drops out, you know why. But here, you don't want to paint over that because it'll short out. What you do is probably put a, over these parts, like here, there's some test points which are just bare tinned copper track. You probably need to put some sort of coating over that with a non-conductive paint. Over here as well, you'd have to watch for all these bits here which are spiky. Anything spiky can actually poke through and pop through the paint. So I would probably just make a layer over that, cover that, just run around. Anything felt like where it's a through hole component, like capacitors, the inductors, inductor and transformer. What else? Your MOSFET sitting there. The rest of it's surface mount, so it's probably not really an issue. But yeah, you could actually paint it all black and see what happens. See if there is a reduction in noise whilst operating the detector. This is probably true for all the detectors. Unless you try it, you don't know. What you could do, and this is just my opinion, is you could get a piece of A4 paper and paint it with conductive paint. Have the detector on and just put the paper over the board. You could probably do it both sides and make sure that you somehow ground it as well. Ground the shield you put on to the central ground point here. There's another one up here too. You can use as a grounding point there and there. So you could try it and see what happens. You would want to have the detector set up in cancel mode if it's got cancel mode, and relatively in a very quiet environment and with measured test targets. And you don't want a lot of noise. You don't want to be near 240 volts or 120 volts or radio stations or cell towers or anything like that. You want to be somewhere. You want to go out in the bush and do this on a card table or some plastic table or something, and put headphones on and experiment in that fashion. Because if you do it inside any lab anywhere, it's not going to work with a metal detector. You're going to have too much interference. It raises the noise floor too much. You won't notice any difference. But out in the field, you may notice a difference with a drop in the overall noise floor of the detector. It's an experiment. You could also get bits of A4 paper as well, or whatever. I just say A4 because it's partially moldable. Or if you really want to go really techo on it, get some cotton paper, what they use for watercolor. That's moldable, and you could actually carbonize the top part and just ground it with a grounding wire, and just probably not with your hand, but if you had something, a decent thick pair of rubber gloves or something, just push it around and see if the noise floor drops, or um, if you can have a uniform swing of a target, something on a bit of fishing line, going back and forth over the coil that doesn't change height, and you can just perceive the signal. Try this bizzo and see if the signal comes up. Any increase in signal is a win for you with your detector. So what I would do is work out what works, and then I'd put it in there permanently. That is me. But then again, doing something like that may just work perfect. Maybe that and some extra close proximity shielding. Maybe even box section shield. Box section shield here around the input stages on the demods and so forth. Here you could put another one here on your receiver input stage. You can put another one here on your high voltage, and not interconnect, but all have them as a common, going to a common ground point. We call it star grounding. It's actually very important so you don't get currents running all over the place and causing havoc. Have it all go back to the central point. So you could try that. You could do a lot of things, like you know you could even, if you really wanted to, you have to be careful, of course. You could paint the top of your um, micros here with conductive paint and ground them. You could put one over here. You could paint your transformers and your inductor. You could paint your capacitors, whatever, but don't get paint on the actual conductive pins of the electronics, because it'll short it out and it'll be doomed. But it is coated, but I don't know how well. You can always get a multimeter lead and stick it on the ground point and put it on high ohms and run around the board and just, lightly touch the tracks everywhere and just see if there's any continuity whatsoever. If there's none, maybe it's okay to do. I wouldn't really paint the top part of the board. It is too risky unless you probably put another layer of paint on the board. But like I say, you don't want to do this with your really expensive metal detector. You want to just do it with some, an old cheapie or something, and just see if the process works, and then just transfer it over to something like this. But you'd have to be careful. Uh, that's just my opinion. You know, keep the noise out. Noise is your enemy when you're detecting. You know that. We all know that. Noisy detector is worse than noisy environment in a lot of cases. It hides signals just as much as what um, all the noise out there in the environment does. You just don't want a big um, you know background of electrical noise. Uh, it's the old story. You got a whole heap of people you know, chatting in a room, and you're trying to hear someone 20 feet away. You can't hear a word they say because it's all just, what is it they say? It's rhubarb. It's going rhubarb, rhubarb, rhubarb all over the place. Um, so same thing. Noise is the rhubarb. With all the people chatting and blocking things out. Get rid of those people, then you hear the conversation clearly, and that's your target. Same effect. So take that into account. But I'm going to do this one and take it out tomorrow and give it a go. I'm going to do some bench tests as well. But I think that I might be on a bit of a winner here with that idea, because it definitely ticks all the boxes for feasibility, and I'd say it ticks the boxes because it's going to do exactly what it does: absorb energy, uh, and will it have enough of an effect to make a change? That is a real question. So we used to do. I'll tell you what I used to do years ago with some of the detectors when they were like the ones with the internal power supplies and that they were noisy. I used to get steel wool, steel wool, that the stuff that goes rusty. I used to get that and throw it in double layered plastic bags and sandwich bags and shove it in the detectors. And just the resistance of that metal in the detector, even though it's ferrous, it's not probably the best thing to use, but it would quieten the detectors down. I kid you not. The old ones, I've done it with the newer ones, it doesn't have much of an effect. Um, it's not the best way of doing it. These things are probably too fast, but the old ones were a bit slower and more sluggish and had a lot more, um, you know, digital noise floating around the board from all that 4,000 CMOS they had in them, and that's just noise generators across the whole spectrum. That stuff. Uh, but when you got most of the clocking done in something like this, and you got proper layered ground planes and stuff in this, they've done everything they can to suppress that type of stuff. But you can't really suppress that, and you can't suppress that. That's still it's even that core structure there is partially open. It's going to radiate anyway. But who knows what hangs around within that quiet time of the receiver. If there's anything just going huh, into it, it's going to desense. It just will. So you can ask anyone about that. I'll tell you the same thing. That's my experience with it all. Anyway, that's another video. It's my last video for tonight. I'm going to try and go to sleep early and hopefully get up before these winds come down here with all this smoke and fire and brimstone. Oh dear me. Yeah, and yeah, me going off about all that, blocking the tracks off. That's valid. That's really valid. And yeah, now let's watch everybody in the community pay the price for blocking off access tracks. My God. No, really. Anyway, I don't want to go on about that because it really is, you know, I sort of get a bit fixated on that because I just can't believe the levels of stupidity, Save the wombats, but we'll burn down humanity. It's stupid. Anyway, my point of view. Sorry, greenies, but most prospectors don't like greenies. Um, they don't, because you keep closing off areas, for our access, for our hobby. Fancy if we cut the beaches off from you or something, or banned hugging trees or something. I don't know. Sorry, guys, but it just, it just gets me. It just does. You know, I, I call a spade, and I call, idiots idiots. It just is. I'm not going to be politically correct. I'm just going to say it as it is. Anyway, that's what it is. I didn't say any really bad words, did I? That's okay. It's not made for kids anyway. So anyway, catches.